Hello and welcome to the session. In today's session, we will be discussing about the algorithm to partition an array. Doesn't seem to be a very big problem, but there are certain reasons for using this particular algorithm because we will be using this particular algorithm in certain applications. So let us first define the problem, like what exactly we want to do, and then develop the algorithm for the same. So the problem definition states, given an unsorted array of numbers having n elements, and the second thing which is given to us is a number x to be used for partitioning the array of elements. So this is the given thing to us. And what is to be done? We need to create two partitions of the array, all the numbers of the array, such that the partition n has values less than equals to x, and partition 2 has element values greater than x. But why do we want to create such an array, or why do we want to create this particular algorithm? Well, such operations are useful in many data structure algorithms like quicksort. And the importance of that particular thing is that if you can use an algorithm to define the larger, given a larger problem, if I can divide that larger problem into smaller set of problems, then I'll be able to solve that particular problem with the strategy of divide and conquer. And this is like the partitioning of array is one such application, right? Which is a very small problem, but can be used anywhere whenever sorting or other things are to be performed. But let us define this particular problem in more concrete way. Let us look into the example for it. So assume marks in an array of integer of size 10. So we are showing this particular marks over here. There are 0 to 9 are the indexes, so 10 values. And these are some of the values which are shown over there. And what we want to find out, all those people who have got marks greater than 75, right? So create partition using x equals to 75. So the two partitions are x is less than equals to 75 and partition 2 has x is greater than 75. Okay. And the integer which we are using, integer array, is this particular an array. So what is our objective? Our objective is to partition this particular array into two parts, right? And that is part 1 and part 2. Now the problem seems very, very simple, isn't it? It's such a simple problem that anyone can do it. How can we do it? Let's look into the process. Suppose this is my array. I can define two more arrays, right? This is simple taking the dump. I read this particular value. Okay, 89. 89 is, it is less than equals to 75. No. So it goes to second array. 66 less than equals to comes to first array. 56 comes to first array. 75 comes to first array. 93, once again, the statement is false, so it goes to second array. 85 goes to second array. 45 comes to first array. And 96 and 76 goes to second array. So what is the big deal of this particular thing? We have three arrays and we have simply put the values into these three arrays and the problem is solved. But whenever we are designing algorithms, what we need to make sure that we design an algorithm which has very good efficiency, and we need to define an algorithm which takes minimum amount of space also, the space complexity which you learn in data structure. So our objective is to design an algorithm where within the same array we can perform this particular operation such that the same array below a particular index, all the values are less than, and above that particular index, the values are greater than, less than equals to and greater than. So this is what now the objective of our problem. Now, as soon as we define this particular objective of our problem, it becomes slightly more complex now, right? Because we have to do it within the array. So now let us try to identify the process for it. Well, let's do with the help of two pointers, right? So let's take two pointers. They are actually indexes. So left and right actually will be integer values in this particular case. And their names are left and right, we have said. Left obviously pointing to the leftmost element in the beginning, and right pointing to the rightmost element in the beginning. So what is our objective? we want to find an index using left till marks left is greater than 75, right? Because all those values which are less than, okay, so we want to bring them towards the left, okay, and all those values which are greater, we want to bring them towards the right, right? So if something is greater than 75, we should immediately stop. Okay, this value is greater than, so it should be put somewhere later in the. As we started, luckily for us, at index 0 itself, we found a value which is greater than 75. So left started pointing to this particular value itself. Now, what is the next thing to do? Next good thing to do is find an index till marks right is less than equals to 75. Okay, so what we are going to do is we're going to be very, very interesting. Okay, first thing, we have found a value which is more than 75, which we pointed to by left. So in the left hand side, that is the kind of value. On the right hand side, we find a value which is less than 75, less than equals to 75. And luckily we found that particular value at location 9. Now is going to be a very interesting thing which we might need to perform. So what we did first, identified a value which is more than 75 using a left pointer, and then we did identify the value pointed to by right pointer which is less than equals to 75. Now this is less than 75, so it should come somewhere in lesser zone, and 89 should go to the higher zone. So what do we do then? The best thing to do in this situation is interchange the two values, right? Interchange these two values, and that's how we will initiate the process of that. On the left hand side, the values are less than 75. On the right hand side, the values are more than 75. Okay, so look into the picture now. So what we did, so we could identify 89 and we could identify 60. And what we did, we interchanged the values between the two. That is, the value stored at location pointed to by left was changed with the value pointed to by right. So if I interchange these two values, this becomes 60 and this becomes 89. Is it the end of the story? Probably not, right? So just exchanging one value does not solve the problem so far. But something has happened that we are now trying to develop an algorithm where within the same array, what we are trying to do, within the same array, we are trying to identify a place where left is less, right is more. That is what we want to do. And what we want to do during the process, identify something. Again, find an index value till left is greater than equals to 66, 56, 75. No, ultimately we need to reach to 93. So we have to traverse through this particular array. We traverse through 66, 56, 75 and ultimately landed at 93. Because the previous values has already been sorted as per the requirement. Now, the similar kind of objective is needed for the right hand. Right hand 89 is already, we have already done the operation with 89. So we will start from 76 and where exactly we reach? A value which is less than equals to 75. 76 is not, 96 is not, but 45 is. Now our pointer left is pointing to 93, which is once again more than 75, and right is pointing to a value which is less than 75. So what should be our operation now? Simply interchange these two values, and that is what we did. Okay, so just exchange the two values, and what we will get? 60, it was already there, 60 and 89 were already interchanged. 45 is now interchanged, 93 is another. So 45 and 93 are interchanged now. So we continue, but there has to be a place where we need to stop this particular algorithm. This particular process cannot go on ultimately. Ultimately, we have to stop this particular algorithm. This cannot go on forever, right? So ultimately, somewhere down the array, it has to stop. And thereafter, we start the process. So once again, when we start, what happens? Left was at 45. So as soon as we move to 85, the condition for left was satisfied. But right, which was at 93, 85 is still greater. Right now has crossed left. Can you see this particular thing over here? That right has now crossed left. Till all our previous operations, left was less than right. But at this point of time, what we found, that left and right have crossed each other. Now that is an indication that this particular process needs to be terminated or need to be stopped. Right? So now we got the basic process and the understanding of basic process and the termination process, how the termination condition will be designed. Right? Now let us try to identify how we are going to perform some of the critical operation in this process of interchange, etc. There is going to be one is going to be interchange, another is going to be identifying which value is less or greater than. That is where the left pointer should come and where the right pointer should be pointing to. Well, these two operations, we define them as important steps. So first important step is how to find marks left is greater than 75 and marks right is less than equals to 75 while the operation. So we go back to this particular array and what we see, our operation should be, and I have kept intentionally the 60-60 stuff because the condition is not if here. The condition has to be while. Why? Because we want to repeat. Because our check is going to be repeated several times. Right? Therefore, we got to use the while operation rather than simply if. And how we are going to check then? While marks left is less than equals to 75. That is the case here. Left plus. You increment the value of left. So how exactly it is going to happen? Left will be moved to 66. Left then will be moved to 56. Then it will be moved to 75. It is still less than equals to. At 93, this particular condition, marks left less than equals to 75 will become false. So that is the point, 93. We will stop at that particular point of time and our left value will be then from this particular 0th location, it will move to location 4. Similarly, on the right side, so we are looking for a value which is on the right side which is less than equals to 75. Is that the case? No. Is that the case? No. No. And this is where we land ourselves. The 45. 45 is less than equals to 75. Can you see the operation difference here? Here we are decrementing right. You can see that every time from 9 we are moving to 8. From 8 we are moving to 7. Keep checking this particular condition. Okay, so that is how in right we are decrementing, in left we are incrementing. So this is one of the operations of the whole process. So one important operation clinched, end condition clinched. But how to exchange the values, right? How to exchange these two values? That is going to be very, very important. Now exchanging the value is going to be very interesting stuff. Many a time, suppose two gentlemen are sitting on two different chairs. Right? And we want to interchange. Now in computer, the most like what we can do physically, one person gets up and second person can sit over there. One person goes on and sit there. But in computer, we need a third place. Why? Because there are values and that value has to be stored somewhere. Okay. The one value which is to be interchanged. First value will be moved to a particular location. Let's say a temporary location. Then second value will be moved to the first location because now first is typically vacant. And then from the temporary location, we will move the value to the second location. This is exactly what we have tried to show you in the important step once again. Interchange marks left with marks right. How we are doing it? Temp equals to marks left. That is what is going to be the first step. Marks left equals to marks right because left has become empty. Whatever value was there in the left has moved to temp, right? So left value actually is empty. So this is something like temp is going to be another variable somewhere else, which is not part of the array at all. So whatever is the value which is being stored at left which happens to be 93, will be moved to a temporary location. And then this 93 is redundant because it has already been saved in the temporary location. So here we will be moving 45, right? That is what is being represented here. Marks left equals to marks right. And then this marks right, here the temporary location, whatever we had stored 93 over there. So we bring that 93 value over here, and that's how the interchanging of the two steps takes place. So that was very, very simple, isn't it? So we were able to do this particular operation without any hassle. So what we require, you see, the small steps are very, very important. If you just can understand those small steps and identify your algorithms in terms of those small steps, you will be able to develop your algorithm. So now let us develop this particular algorithm. Let's look into the slide for the algorithm. First thing is, whenever you are trying to do anything, it is actually we have developed the program itself. So first thing is defining the variables which you are going to utilize within the program. And this particular include stdio.h, you know, this is a preprocessor statement. It has nothing to do with it. But here we are doing n. N happens to be the maximum value we are assuming. So number of elements in an array. So number of elements in an array we are assuming to be 10. Okay. And then we define here. We have defined the array of size 10, which happens to be n here. A temporary variable which will be required for exchanging, right? A pointer left, which we have named as L, and pointer R. L has been initialized to be 0, right? And you remember the lowest index is 0 and highest index is 10 minus 1, 9. So that is how n minus 1 is always there in C. C, this is the state. If you have defined an array to contain 10 elements, then it will be between index 0 and 9. So 10 elements like that. And another variable I, which we will be using in iteration. First, we read this particular array in which all the values needs to be found. Now, that is very, very simple operation. So I'm not going to dwell on reading as far as is concerned. But the only hint to you is before reading, you display something, right? So you use printf and then only use scanf in C. So you read those particular values, read the values of array. Now is the actual algorithm stuff. So what we do then, so look into the algorithm please. Find first left and right indexes. When marks left is greater than 75 and marks right is less than 75. This was the operation which we did. We just explained that. And this was the while loop which I just explained to you. While marks left is less than equals to 75, keep moving L++ till you find the value which is more than 75. Okay, here anything marks, if they are greater than 75, keep reducing the value of R, right? Keep moving down. And then is the most important step. And what is that? While the value of left is less than the value of right, this we have to check. Why? Because what we saw in our process, if left crosses right, the moment it happens, left crosses right, that is the process of termination, right? So we had to stop at that kind of a time. And that can be done with the help of a while statement. Because even the process of interchange has to be repeated many a times. And that is why this particular while condition, right? So if that happens, we interchange. You remember the interchange sequence we did at that point of time? Once we have interchanged, we increment left because already now whatever L was pointing to, now that value has already become less than, right? So it satisfies the condition which we wanted. Okay, and R we decrement. So we move L and R once again. And then in the next iteration, in the next step, we once again find the value of new L and new R. Okay, so this is the way we try to find the value of new L and new R, and this is the end of the, basically shows the end of the algorithm. So the most important condition is if L is less than R. Now you may be wondering why I have used two whiles in this particular case. While two whiles, same step, right? Now typical cases in you see, whenever we are trying to develop an algorithm, one of the important thinking is that under what condition an algorithm may fail. Well, most of the algorithms, when we design, we don't test them for all the conditions. And that is why most of our algorithm fails at some point of time. The values, it's not that they will fail under the normal condition, but when some typical condition occurs, then many of our algorithms can fail. And that can cause major harm. That can result into major problem as far as implementations are concerned. Think of a situation you have done in a very human critical system. You have implemented the sorting algorithm, and suddenly in the sorting algorithm you implemented, obviously you can implement quicksort, which happens to be one of the fastest average time behavior. Now that algorithm, if it fails because of this partitioning algorithm, then there can be problems, right? And one of the first principles of software engineering is that you got to test your system to as far as possible. Otherwise, the chances of failures are very, very high. Okay, so one of the principles there, we have to deal with that particular situation. And that was the precise reason. First, we found out a value which was of L and left and right, which happens to be at some point of time initially. So the first value needs to, whenever you are utilizing while, what happens? While takes the value to a distance. Suppose in the first case you keep on moving, and while takes you to a distance, and the second while takes you another distance, and there is already a crossover. If you don't check whether left is less than right? If we don't check, then our algorithm may fail. Okay, so that is one of the precise problem. Now, another interesting situation which is there, when do we stop? When do we stop? When, I think I'll take you slightly back, right? So this was the condition. Okay, now what output should be generated by our algorithm? We have not shown any output as far as that algorithm is concerned. But what we are sure of, that the left pointer will be stopping where a value which is more than 75. It is always going to stop at a value which is more than 75. That means when left and right has crossed each other, then from 0 to left minus 1 is the first partition. Can you see that? So you need to return what? The value of left minus 1. And where is your second partition? Your second partition is from left point till the end. So this is how you really need to look into your algorithm whenever you are doing this particular thing. Now, even this algorithm may have certain problems. When all the values are the same, this algorithm may fail. So you really need to look into your algorithms, check for the error condition, and then only you will be able to come up with better algorithms which do not fail under the conditions, right? Thank you so much. Thank you for being with me.